On the next tab, I'm going to add some of the button functions that control the pop-up pages. If we take a look at the touch panel design for a moment, you'll see that there are different pages that need to be displayed depending on whether the room is open or closed. When it's closed, I need a page that shows the input buttons for that particular room. When it's open, however, I need to see all the inputs in both rooms. The first thing I need to do on this tab is to add a UI control node. This is used to monitor any button pushes or level changes on the panel. This first node is going to monitor the Start a Presentation button on the menu page. In the trigger setting, I can look for either a push or a release, and in this case, I need to know when the button's been pushed. The button's state setting controls whether the button feedback is on or off. As I'm not using feedback on this button, I'll leave it set to off. To complete this, I'll name the node so I know which button it relates to. Now it's best to keep this similar to the name on the panel design to avoid getting confused. Once the button's been pushed, it creates a trigger for the next node. The first thing I want this button to do is to close any existing pop-up pages that are already open. The Navigate node is the node that we use to send commands to the touch panel to switch between different pages or open and close pop-ups. In this case, I need to select my touch panel and enter the command !ppx, which is used to close all the pop-ups. Once this is named, I can close the settings and connect the two nodes together. Now the pop-up page I want to show is going to be different depending on whether the room is open or closed. So the next step is to check the status of the I/O port on the control extender. And for this, I'll use a status node. I'll change the name of the node to room status and then select the device, which is the CEIO4, which is the device name I gave it in the control processor itself. I'm using the first I/O port, and this is set as a digital input. When the status node is triggered, it'll send a command to the control extender which returns the current value of that I/O port. Now at the moment I don't know what format this message is going to take, so before I carry on, I'll test it using an inject and a debug node. The inject node can be used as a trigger in the same way a button push would be, and the debug node is going to show me the message that's been returned from the device when that node is triggered. Before I can test this, I need to deploy the flow so that any changes are now running as part of the program. And now when I trigger the inject node, the debug window shows me the response. If I change the contact state in the room, we should see a new message. So true means the room is open and false means it's closed. I can now use this information to manage the pop-up pages. To do this, I'll use a switch node. This node looks at the incoming message and then triggers an output depending on the message contents. This node has one output by default but can have as many as you need, so I'll add a second output. One of these is set to true and the other one is set to false. I'll call this node open or closed so I know what it's doing. Once my switch is in place, I'll need two navigate nodes, one for each of the pop-ups. When I've selected the panel and the page I want, I need to add in the command before the page name. In this case, the command I need is !ppn. Rather than dragging in a second node, it's quicker to copy and paste this node and then change the settings. Don't forget that when you select the page, you also need to add the ppn command because this gets removed when you select the new page. Now I can join all my nodes together, making sure that I use the correct navigate pages on each of the switch node outputs. As well as opening the pop-up, I need to be able to return back to the main menu, so I need to add another UI control node, this time monitoring the home button on the main page. Again, the trigger is when the button is pushed, and I'm not using feedback, so I'll leave the state as off. I've already got a node to close the pop-up, so I don't need to create a new one. I'll just copy and paste this one and use it in this flow. Now I can add another navigate node and choose the menu page as the pop-up that I want to display. Once my nodes are connected and the flow is deployed, we can test the system. As MUSE uses scripting languages, there's no code to compile and upload, followed by long reboot times, so it makes it really quick to test everything one flow at a time. As you can't see my touch panel, I'll use a VNC window. This seems to be working fine. When the room is in open mode, I get all the inputs, and if I change the room state to close using a test switch that I connected to the control extender, I only see the inputs in the first room. One thing I haven't done at the moment is to switch anything on. I could send a command to switch the display on when I press the presentation button, but rather than sending this command every time, I'll query the display to see if it's currently on or off. I'll use a status node for this, which I'll call display power status. I'll select the device I'm querying, followed by the parameter, which in this case is the power. I know this is going to return either an on or an off, so I'll add a switch node, but this time I don't need to add a second output because I'm only interested in knowing if the display is off. So I'm looking for a message payload equal to off, and I call this node power off. I'll use a command node to switch the display power on, and I'll give it a name that references what this command node actually does. When this flow is connected and deployed, if I press the presentation button, the processor first checks the power status and only sends an on command if the display is currently switched off.